kind of give it any valid sort of email address, and you should get connected. I did want to mention there's a code of conduct that we adhere to, which is the Go Community Code of Conduct, and you can search that. It's the Go community is actively trying to get meetups and groups to adhere to this, and it's basically just be very respectful of each other, and no discrimination. We're trying to be a very open and accepting and everything community. So definitely, if there's any issues you see, please report that to either me or the Go Community Code of Conduct organizers at conduct@golang.org. And I also normally ask for talk submissions and speakers for the upcoming year, but we are actually pretty packed for this year. I think we might have 1 or 2 slots. If anybody's interested in speaking this year, please talk to me. I think there's maybe September is open and maybe October, I don't know. But we've been really lucky to have a lot of people sign up this year ahead of time. So, and in sponsorship, I'm not sure if all these speakers have sponsors, but we're always willing to talk about sponsorship. I think we offer a really good deal on that. I think that's all the stuff that I had to say. I do want to mention next month we have Jeffrey Doricott here speaking about distributed tracing and Jaeger and open tracing, and that's really hot stuff. I'm excited about that, so please come next month as well. The month after that, I'll be talking about Go modules and dependency management. So that said, I think we'll, with the musical interlude, we'll start with, can we have pull requests talk about what pull request does, jobs, anything you'd like to share with the group?
How's it going? My name is Patrick, and I'm one of Tyler's co-founders of Pull Request. So, yeah, come on in. I wanted to give you guys a general sense of who we are and what we do. So we're Pull Request, and we're a Google-backed startup, specifically Gradient Ventures. And we went through the Y Combinator Seed Accelerator in summer 2017. We're based here in Austin, in fact, right across the street at Paradox Tower. And our team is just really excited about code quality, specifically code review. We think it's fundamental in improving code. So we're building a platform for code review. And the ultimate goal is let's help development teams of all sizes step up their code review game so we can catch bugs, catch security vulnerabilities, enforce best practices, and even speed up the development cycle speed, right? So how do we do that? Well, we've accumulated a huge network of super talented engineers who share our enthusiasm for code review, and we've equipped them with automated tooling, static analysis engines, linters, and using our platform they're able to review our customers' code right in our customers' CI/CD workflows. So really exciting stuff, the ultimate goal being let's make code better, right? So yeah. Oh, I do want to mention before I hand off that we are hiring, as was mentioned before. Just looking for talented people who are also interested in this sort of thing to work alongside of us internally as well as reviewers within our network. So if that's something that might interest you or someone you know, feel free to reach out. We have job postings as well as there's a handful of us here tonight, so if you feel so inclined, come chat with us after the talk. With that, I'll let Tyler.
Thanks, Patrick. Yeah, so if anyone has any questions about pull requests, you can either ask us now or hold them for the end and talk to us. And if you're tired of not getting your code reviewed at your company as well, you can try to ask your manager to sign up for us. So yeah, I'm Tyler Mann. I'm the CTO and another co-founder at Pull Request. I'm going to be talking to you today about code review, specifically in Go. So my main goal today is to give you, everyone here, some sort of takeaway that tomorrow you can go back and if you're either involved in code reviews, whether it's your code getting reviewed or reviewing other people's code, you'll have some takeaways from here that you can do to improve that process. And a lot of this is not completely specific to Go, but I'm going to use Go for all the examples. But code review kind of applies to any language you're doing. So even if you're not doing Go in your day-to-day, which I know I've talked to a lot of you here, and like you love Go, but you work in another language at your current job, hopefully this will help you even with that. So yeah, here's a quick overview. I'm just going to give you a little background on me and why I'm talking to you about code review and sort of where I'm coming from, because everyone's background is a little bit different, and that kind of affects the type of comments they give and what they care about in code review. But we're going to then talk about why people code review and what makes a good code review. And then we're going to go into some specific examples. And the examples I'm going to focus on are things that we see a lot in our network, because we see a ton of code reviews come through. So I'm going to try to highlight a few things that are pretty critical issues like security, error handling, and concurrency. But there's a ton more that I'm going to be able to talk about tonight, obviously, for code review, so that we're just going to focus on these few things. So really quick about me. So I actually started out as an electrical engineer and have kind of worked my way up and down the stack, doing stuff all the way from UI or iOS app development, as well as a lot of back-end stuff. So that's going to kind of affect some of my perspectives on what I've seen. But I've also worked at very large companies like Cisco, as well as really tiny startups. And I worked at Dropbox for a while. And while I was at Dropbox, my team, I was on the iOS team, and there were 3 of us that were maintaining the iOS app. And we had about over 10 million daily active users at that point in time using the app, and there were only 3 of us maintaining it. And we'd inherited this app that had no unit tests, no automated test coverage, and so really we didn't have a QA team either. We had to test everything ourselves. So the only way we were able to uphold quality is we just really cared about code review, and that was the first experience that really kind of showed me the value of code review and what you can get out of it, and how you can maintain a high quality app. And we ended up maintaining a super low crash rate compared to a lot of other apps, and we're able to do that through the code review process. And so obviously now I work at pull request, and our company here, we've done a ton of code review, obviously as a code review company, but starting out the company, we went through Y Combinator, and even now we do a lot of code reviews internally. So you can imagine when you're first starting, if you're first starting like Uber, you're gonna have to drive some of the early cars yourself to get customers to rides. Well, similarly, we were fulfilling a lot of the reviews ourselves early on, and in fact, all the reviews for our first customers. So I've done a ton of code reviews through that process, and our team has, and so from that, we've learned a ton. And it's still in our culture today. We try to make sure every engineer is reviewing some customer code through our platform on a weekly basis. So is anyone here not familiar with code review or not do it in their day-to-day process? Okay, so there's a few people. Yeah, so basically what code review is, for anyone who's not super familiar, it's basically peer review. So you're making changes to your code base, you're usually working on a team, and someone else in your team is going to look over those changes, suggest any feedback, and it usually happens right after you finish developing, before you get to the QA stage. So that's what we're going to be talking about, is code review in that sense. So why do people code review? Do you guys have any, let's see if anyone here in the crowd has an idea of why you code review, or what's the main reason you think people code review? Anyone? Yeah.
It was like the Linus Law thing, that all bugs are shallow given enough eyeballs.
Yeah.
Only having 2 eyeballs isn't quite enough.
Yeah, exactly, to get more eyes on it.
I use the joke that even Stephen King and J.K. Rowling have an editor, someone else who looks at it. And,
exactly.
And I found that lots of developers are a little offended that they feel like someone else has to check their stuff, and then they're the 2 best-selling authors probably in the world, and they still have an editor. There's probably something to it.
Yeah, exactly. It's something that, even the best programmers in the world get their code reviewed. So yeah, the first thing I have here, similar to what you guys were talking about, is to deliver a higher quality product. Every top tech company, every product that you've used that was actually a well-formed and functioning product is probably code reviewed. Obviously, GoLang's code reviewed. Even the creators of GoLang get their code reviewed by other creators so they can maintain the quality. Because writing code's hard, and yeah, if you only have 2 eyes looking at it, you're gonna kind of lose track of issues that you might have made or mistakes you might have made. And the other thing is, so code review is or writing code is a pattern matching process. And so just getting more eyes on it, you're going to have more collective patterns that people have seen, and they might identify a mistake they made in the past. And then there's just some issues that you can actually only catch through the code review process. So even if you have unit tests, and even if you're like an amazing developer, there's some types of issues that your QA or CI/CD pipeline may not catch at all, even if you have full test coverage. So we're going to talk about some of those later, some examples of that, and how to look out for that. So the other reason code review is to improve readability and maintainability. So as I mentioned, like software's been built by teams. So because of that, you should always optimize for readability first, at least in my opinion. If you're a really new project and you're just trying to get a prototype out, you can kind of avoid this for like the first month or so. But in general, any maintained project, you want to be optimizing for readability, because there's a lot of studies that have shown like about 90% of the time of a code's lifespan, it's spent being read instead of written. So if you want to like actually improve the maintainability, like getting another perspective and focusing on how is this the most readable to a new person to the code base is really important. And so the other thing, sharing knowledge and leveling up. So I don't know how many of you here are like somewhat new to software engineering, whether it's like your first year, even if you have a few years under your belt of doing software engineering. One of the best ways in my experience to like really level up your skills is to read the code of really great engineers that have built things that you like. So if it's GoLang, start checking out the source code for Go, and you'll see, even if you don't understand it all right now, you'll see good patterns that you can use in your own code. And so similarly, being involved in the code review process, whether it's reviewing your teammates' code or having your code reviewed, is one of the best places to like have that learning cycle and see how other people are doing things, as well as just getting feedback on the mistakes you're making. Because like the quickest, in my opinion, the quickest feedback loop for learning, and learning is basically the process of having failures and then being corrected and kind of learning not to make those same failures in the future. And the quickest process for that in software engineering is code review. So if your team's kind of skipping that or just blindly approving, then you're really missing out on advancing your skills and just your knowledge as an engineer. So the other part of code review that is the reason people do it is, so the software development lifecycle usually starts with planning, then developing, then code review hopefully, then hopefully you have some kind of QA, and then your code goes to production. So this graph here basically represents that process, but the vertical graph is, or the vertical axis is the time cost of finding an issue at that stage in the life cycle. So obviously, like if you're planning a new feature, that's the best time to find an issue, because if there's like a requirement that someone didn't think about, you can easily add it into the spec. No code's been written yet. It's a really easy mistake to correct. Once you get to the developing stage, it's going to be a little bit more complicated. You might have a bug that comes up that affects the architecture, and you may have to go back to planning, but it's still a great place to find an issue. Code review, similarly, at this point, the developer may have spent a week or more writing this, but at the same time, the feedback or the code is still top of mind of the team and that developer. So any feedback that comes there and you have to refactor or fix bugs, that's still not a bad place to catch an issue. But once you start getting into QA, a lot of times the code's already been merged for a week or longer, and it's no longer top of mind, and the QA representative may not have the best repro steps to help you identify what the issue is. And a lot of times at this point, it's going to get punted all the way back. You're going to have to develop again, you're going to have to do another code review, and then it's going to go back to QA. So that's obviously not ideal, but production is the worst. If your users are getting your bugs and you're catching an issue after it's already in production, you're really going to be having to, then first of all, your users are going to be angry, and then someone's going to have to file an issue. You're going to go back to planning and schedule an engineer to fix that issue, and then someone's going to have to develop a fix, and you go back to code review, so on. So this is just trying to illustrate that the earlier on in the life cycle you can catch issues, it's super important. And code review is, if you're missing out on that or you're not taking it seriously, then you're going to miss a lot of valuable, you're basically going to waste a lot of valuable time in your company. So what makes a bad code review? So I already mentioned this before, but doing like a looks good to me stamp with no feedback, like this, in some cases this is fine. If your team has a good code review culture and you say looks good to me, and you don't normally say that, then someone might actually, they probably believe you and it's probably a valid response. But if you're doing that and it's a giant pull request, that's usually a bad sign. And I mean, I've been there before, I've seen that happen like in the past. Everyone does that, but you're kind of doing yourself a disservice. It's actually even worse than not reviewing it at all, because now the person thinks that, okay, this is good to go. So don't do that. The other thing that makes bad code review is suggesting changes without a clear value add or reasoning. So you can read the little Dilbert comment, but yeah, basically if you're adding a comment to a code review, you want to make sure that you're not just saying, I don't like the way this code looks, or I don't like this, you should change this. Like, you should give some sort of feedback on why you're suggesting that, and then ideally even give an actionable step they can take to fix it. But even if you don't have that, at least give reasoning, because this seems like it should be obvious and like you don't need to be hearing this, but we see this so often, and as we're involved in other customer code reviews where people will be somewhat hostile and or they're just really short with their comments and they don't give good reasoning. So another thing that, and this is my opinion of what doesn't make a good code review, is if you're leaving a lot of formatting and style nitpicks. So you can see here there's like an extra space before the function name, the tabs are off and everything, tabs versus spaces. But if you left comments like this there, it says, can you remove the extra space and yada yada, you're going to end up polluting the code review with a lot of things that don't functionally matter. So it's much better to try to use like an auto formatter, and luckily GoLang has that built in with Go format. I think it's included in the standard library, but if not, everyone pretty much uses it, and you can hook it up into your IDE to auto format the code, and then no one has to worry about commenting on spaces or whatnot anymore. And I can show you, I have an example really quick here, so I don't know if you guys can see this, but yeah, so if I hit, this is Visual Studio Code, which I recommend if you haven't already picked an IDE to do GoLang in, but it works really well, and you can set up Go format to every time you save, it just auto corrects everything the way it should be formatted, and you'll never have this problem again in your code review. So even other languages have this as well, so I would always try to like figure that out for your language and get it auto formatted that your team agrees on. So other thing, so what makes a good code review? Method of tone and method of delivery. So yeah, there's a kind of meme here of Linus Torvalds. He's known for being obviously a genius, but he doesn't follow the Go code of conduct, and you should report him. It's like, it can be kind of funny, but at the same time, in reality, like it's not a good way to do a code review, because you're going to be like distracting from the actual content, and all of a sudden you're abusing people or calling them names, and it's just not a good process. So, but at a more micro level, like obviously at most companies this wouldn't fly to act like that, but on a more micro level this does happen every day, and you'll see there's a lot of sort of kind of tension between employees at companies that I've seen and experienced in the past, where like people leave sort of passive aggressive comments or kind of always pick out bad things that an engineer is doing, and it can make the process like not fun for everyone. So like a really easy thing you can do, and this applies to like, even if you're a manager for an employee, you kind of learn this like sandwich technique of like you give positive feedback, you give some critical feedback, then you give more positive feedback. But you can incorporate this in your code review. Like almost no one does this, where they'll point out, oh, good job doing this thing, or this looks good. And people try to just be critical, and sometimes they'll be like kind of passive aggressive about it. So I would try to focus on that, and that's a really good takeaway that you can probably try out tomorrow. It's just like comment, if someone does something cool, comment on it. Also just asking questions, like your team, you should feel comfortable asking a question in a code review on a line. and not have someone like make fun of you. But also because asking a question can a lot of time lead to, even if if it doesn't end up being an issue, a lot of times as an author, I've had people ask me questions and I realize something else myself just because of the way they made me rethink about something. So it can be really useful. So similarly, we've already talked about most of this, so I'll breeze through this, but just noticing things that the author won't see, readability, just getting a fresh set of eyes on the code. So this one, anticipating future usage, is actually really important. So this is kind of the point of like, if you have unit tests on and really good automated tests set up for your code, you might be catching, a lot of times they can be set up just to like test the current state of the code, and it's just a point in time where this looks good, but you're not actually protecting yourself against the future and how people might change the way your code works. And so you should always kind of think about, how can I be a little bit defensive so that when either I come back later and edit this, or my coworker comes and edits this code, they're not going to break something and it's not super fragile. So again, that goes back to that whole slide I had on the software development process, where it gets harder to fix things after they get into production. So you can really save yourself time there by making the code really readable up front and defensive. So one way to do this in GoLang is using a technique called encapsulation, which you can do in pretty much any language, but in GoLang it exists through using interfaces, as well as in GoLang, for those of you that don't know, if a variable or function is lowercase, it's not exported from your package. If it's uppercase, it's going to get, or the first letter is uppercase, it's going to get exported. So that's another way that you can basically figure out, what are the things that I care about someone outside of this being able to access, and what do I not. And a good way to do that is using GoDocs, which you'll see all the documentation online. People use GoDocs, and if you run GoDocs over your code, it'll find all the public things and it'll show you what your API looks like. And a lot of times when you do that, you'll be like, oh, that really doesn't need to be there. So it's a good technique to do. So here's an example of encapsulation. This is a really simple package that just has a counter struct that has an internal value, integer, and it just has a method implemented on it for increment that's doing ++ on the value. And then after it does that, it prints out the new count. So updated count to, and the new value. So in this example, you can see the counter is capitalized, so it's exported. The value is capitalized, it's exported, and as well as the increment. So you can change that. So this is a way that someone might abuse this, is they might, this is obviously a very contrived example, but they might create the counter, call it increment, and then you see a log that says updated count to 1. Then someone mutates the value to be += 5, so now the count is technically 6 at this point. They call increment again, and it says updated count to 7. So in this case, if you're reading the logs later as a developer, you might be like, well, I thought I was supposed to always increment by 1. Why does it only have 1 and 7, whereas like the 2 through 6? And so you can protect against that by using an interface, or you can lowercase the value on the struct. Ideally, an interface would be better here. But this is just an example of like that value, if you didn't intend for it to be used that way, just don't export that. So, all right, so now on to like more of what makes a good review and like inspection of edge cases and critical sections. So I'm going to talk about security first, and so this is kind of talking about like web applications security for the most part. And this diagram I made basically to indicate, as you're going through like the API lifecycle, you're going to come in through one of these APIs, and there's different layers of your code base that you're going to have to navigate and think about security. So the first one is going to be authentication in most cases, and just verifying that you know who this request is coming from. Then you're going to have user permissions, where you have to verify what does this request have access to. And then there's all kinds of things in the application code around querying databases and HTML templating, where you can accidentally introduce injection vulnerabilities. So we're going to talk about authentication first. which authentication, for anyone who's not familiar, is verifying the identity of a user. So in this case, you have this like gray question mark gopher. It's making a request to our site. We don't know who it is. Authentication is the process of identifying that, okay, this is the blue gopher. It's that basically trusting who this is that's connecting to our server. So there's a lot of different types of authentication. There's basic auth. Everyone knows like usernames and passwords. There's signed requests using asymmetrical cryptography, which could be like SSH keys and SSL and all these techniques. There's secret keys, API tokens. These kind of are super common, but the main thing I want to point out here is don't invent your own authentication unless you know exactly what you're doing, which there's few people that do. And a lot of these techniques you see here have been like abused over the years and hardened into place to a somewhat secure version now. So yeah, just whenever you're thinking about authentication, you want to think about what package can I use that's built in commonly used in the standard library or in my framework that I can trust. So that's one thing to look out for. So here's an example of some code that is generating a new API key, and it's basically taking a random character from the string of letters, which is like the alphabet and some numbers, and it's making a 20 digit long string and printing it out, or just returning it. So does anyone see what's wrong with this? Yeah.
You're using mathrand.
Yeah, so mathrand, although built into the GoLang package, and most other languages have, or framework, and most other languages have a mathrand type package as well. It's not actually meant, even though it does random strings, it's not meant to be used for generating keys. So instead of using mathrand, I'm going to show you really quick why you don't want to use it. Just one reason why you don't want to use it, but this is basically the exact same code. In this code, you can actually find, like, copy and paste it on Stack Overflow all the time. So this is just an example of something you want to, like, avoid. You want to make sure you look into the best practices for the language if you're doing anything with cryptography. But so here's that generate new key function, and I basically just have it hooked up to a main function here that's printing one of these keys. So I'm going to go into so here's that file. I'm going to do go run. All right, we got a new value here. So yeah, we got a random string here. This looks good, right? This looks like it should be random. Let me try running it again. Okay, we're getting the same random string every time. So the reason for this is like math.rand is meant to be used for mathematical purposes. It's always seeded with the same value intentionally, so you're always going to get the same sequence of random numbers. You can seed it yourself and actually change it to return a different one each time, which is actually not really much better than the existing version of this, because whatever you seed it with, unless you're using a secure API key or some kind of secure data, is going to end up having the same issues because there's just not enough entropy. So a lot of times people recommend online things like, oh, well, seed your mathrand function with a timestamp. But there's not a lot of entropy in a timestamp. There's not a lot of randomness. And it's really easy to, as an attacker, figure out when that timestamp was created, especially if you have another vulnerability that you can exploit. So don't use mathrand. Moral of the story there. But so in key generation best practices, you should use crypto/rand instead, which is built into GoLang. So you should always look for keywords like crypto or secure when you're dealing with random numbers. And similarly, there's higher level packages you can use, like Google has a UID package that creates random UIDs. And if you check out their documentation, they'll say in here that it's based on the strength of crypto-rand. So always look for that if you're ever using something that's generating an API key or some sort of random, something that you expect to be not guessed by another user, basically. So here's an example of some code that is basically creating two API handlers. The first one's an account API to get user account details. The second one is a messages API to get user messages. And you can see these both at the top are calling authenticate request. So they're both authenticating the user. But one thing that I recommend, and most people will recommend to you, is to use some sort of middleware to limit the places you're doing the authentication. So in this case, this is a case where like I talked about before, where this point in time, this code is fine and this is secure in this method. But over time, as more developers work in your project, if they have to always remember to authenticate requests to the top of each function, then you're just setting yourself up for someone to accidentally forget it one time. And they might open a review and all you can see is the lines being added and they have a function there but they didn't add it and you might not call it out. So you want to try to, generally in security, if you're doing something related to like a secure operation, you want to see if you can limit that code to only be in one place and applied across the board. So here's one way to do that in GoLang. It's not the actual HTTP server. I don't think you can do middleware by default, but you can, or at least not in this way, apply it to multiple routes. But this is using Gorilla Mux, which is a really popular routing library, and you can basically apply the auth middleware. And what that does is make it so that any future API handlers you implement off of this will already be authenticated. So, all right, now moving on to authorization, which sounds similar to authentication, but we're now talking about giving permission or authority. So you can see in this case we have the blue gopher. We already know, we trust that this is the blue gopher, but we want to know what should this blue gopher have access to in our system. Similarly, the brown gopher should only have access to the brown stuff. So that's the process of authorization, and it's often called permissions as well. So here's an example of, this is actually something that we've seen a lot at pull requests. I've seen this bug probably 3 times in the last year being introduced. And basically what's happening here is, this is like a permissions function that someone's built that takes a user and an entity, and it's checking if, it used to be checking if the user was a member, and if they own the entity, then it returns true, like they're permitted to access it. And then it got changed to allow admins to also see that entity. So in this change though, it's checking if the user is an admin, then it returns true. If it's a member, it returns true, or if it owns the entity, it returns true. So the problem here is the last or should be an and, but I purposely tried to make this one really readable. The other ones I've seen are usually more complicated logic, where someone's got like a few knots in there and you can't really tell what's going on. But even with this case, it's 2 characters that are off, and this is all of a sudden opening it up so that any member that calls this is going to have access to any other member's data. So this is the kind of thing that you want to really be careful of looking at in a code review. Because actually in the most recent time I saw this, there was also a unit test being added that tested that the admin had permissions, and there's an old unit test that tested the user has permissions, but there weren't tests that test the inverse, that a member that doesn't have access doesn't have permission. So it's something their test coverage probably said 100% coverage, but you still want to always, if you're ever looking at a code review and there's something related to permissions or any sort of basically user security issues, you want to make sure you pay really careful attention to every logical statement there. So here is another, this is another API handler basically, which is for an API that would be user / and then the user ID to get the account info. We're doing authenticate at the top, which we already talked about. We'd probably put that in the middleware, but ignoring that for now. After that, we grab the user ID from the API route, and then we're looking up the user for that user ID, and then we're getting the account for that user, and then we'll end up returning that account for that user. So this is another case that I see really often. Reviewing code, and it's fairly easy to make. And basically the problem here is the user ID so we're authenticating, we're verifying that this is a real user, but we're then taking the user ID from the API route, and we're just using that to look up that user by ID. So we sort of bypass that permissions layer where, in this case, it's like we know this is the blue gopher, but if we were to pass the brown gopher's ID there, then it would still allow us to access that user's account info. And so one way that you can really look out for this is there should almost never be a user ID in a route, in an API route. There's two cases where there can be, and one of them is like if it's a GitHub type service where you have public user profiles and people might be looking at another user's profile, but that's not super common, and like it's probably still worth calling that out in a code review if you see a user ID in the route. The other case is if it's an admin API only and it's meant for admins to look at other users' data. But again, you probably want to, either of those cases I would call this out, because yeah, it's very common, and the problem with this is any of these permissions issues, you don't notice it, like you're not going to notice it early on. It's going to get, if it gets in to your code, QA is not going to notice it, because your code, your web front end or something may not ever call the APIs in this way, but someday some like attacker or hacker or whoever is going to like try this out and try calling another user ID, and especially if you're using like incrementing user IDs, they could just walk this and like scrape all your users' data. So it's a very tricky thing that you want to keep an eye out for, is like making sure that you're extending trust. And so the word extending trust that I have here, like the way to think about this is like you authenticate the user using cryptography that makes it so you trust this user. You should always then, any other queries that you do related to user data, you should build off of that user ID or that user that you've already trusted. So you want to always have a path of that trust that extends from your authentication to whatever resource you're going for. Because this bypasses that, this basically splits it. All right, so we're going to talk about error handling. So error handling in a lot of like older languages like C, some in C++, Objective-C, people used to return error codes as like integers, or even like Bash if you're using command line. You return like a 0 for success or some other number for different types of errors. So there's other languages that do exceptions as best practice, so things like Python, JavaScript, Java, PHP. And GoLang, obviously for those of you that are familiar with it, errors are an interface that's returned by a function. And it's a really simple interface. It just implements one method called error that returns a string. And so the first thing to know about error handling is always handle errors. That's like pretty common in most, a lot of code that you see. It's really easy as you're like developing to just like skip the errors and not deal with them, but you should always handle them. And unfortunately, GoLang, I wish there's probably like settings to add more warnings, but you can ignore errors fairly easily by just like not having return arguments set to anything. So what you should do with an error once you get it to handle it is you should always either pass it back in your return value to whoever your caller was, or you should log it to some sort of service so that you know what happened with that error. So similarly, there's other ways to do errors in GoLang. There's fatal F and exit, which I wouldn't recommend. Like, you're not really supposed to use those unless you're doing it in your main package, because it's going to take down the entire application. So mostly stay away from that and just return errors. There's also panics, which are like exceptions, but similarly, I'm not going to talk about them much today, but similarly try to always use errors and only use panics sparingly. there's problems with using panics. If you use a panic in a Go routine and you don't recover from it, there's no way to recover after that, and it'll take down your whole app as well, at least as far as I know. And so here's an example of some error handling in Go. So there's one thing that I would recommend here off the bat, which is if you look at it, it kind of like keeps indenting more into the middle of the function. In some languages, this is called like the pyramid of death, but you don't want to do this because it'll keep, if you have more complicated stuff here, it'll keep getting further and further to the right. So GoLang always recommends to try to keep the normal path at minimal indentation and instead indent the error handling and deal with it first. So you can see like the first if statement here, we're checking the error, and then if it's equal to nil, which means there's no error, then we go into that. So this is actually the success path is going into the middle of this function, and where we return nil in the middle, that's actually the success case where this method didn't fail. So instead, you want to reorder it so the success case is now at the bottom, and you're handling each error as it happens. So the first error, if it's not equal to nil, you're going to return it. Then we're going to do something again and return an error. But in this case, there's still an issue that I would point out with this code, which is that the second error here is being discarded. So you can see we're checking the error is not equal to nil, and then we create a new error that doesn't include that old error's context. So you're not actually going to know why do thing again failed. You're just going to know that it did fail. So you should always want to include that original error context. But the other thing you want to do, even in this case, so here we're always returning the errors that failed. Ideally, you use format error f to merge the context with additional context. So in this case, we are using format error f, and we're prepending a string that says failed to do thing, and then we do %s and include that error. So it's going to basically keep appending on this error string. And this is kind of how you build like a stack trace in GoLang in some sense. So this way, each of your functions, as you go down, you'll have like some context of where it failed. And because otherwise, if do thing and do thing again both returned the same error from whatever their internal thing did, then when you're looking at the debug logs, you would have no idea if it hit do thing or do thing again case. So you always want to keep adding this context so that it'll really help you debugging once things start messing up. And I learned this the hard way. Like, there's nothing worse than getting like a debug log that you're like, I have no clue where this came from. So you should always like try to help yourself out in the future and do this. This is something you can probably find in like almost every Go review unless you're really careful about it. So in order to show that, while I was doing this talk, I found a random PR on Kubernetes that this is from one of their core contributors, and I was just like, hey, you might want to use error f here. As you can see, this is kind of the exact same case where they're returning the error, and sure enough, they ended up adding that fix, because in this case, they were doing JSON Marshal a few times, and it's possible if they hit one of those, they might not know which of the cases it hit. And this is actually in their style guide to do this, so it's just easy to forget about it and return the error. So Go standard library only has this one error f to basically chain context onto errors. There's a package that's really common that people use called package/errors, and it has a wrap method that you don't have to do the whole %s thing. And it will sort of build a stack trace for you. When you print it out, it prints out kind of vertically, which is nice. But that package has actually gone into just maintenance at this point, because in GoLang 2 that's coming up, they're going to be updating the way errors work. And so because of that, they're holding off on adding anything else and hoping to get it all into Go 2. So hopefully this will be a little better in GoLang 2. And this is a comment from what they're planning on updating in GoLang, which is they've recognized error f is really only good for humans to parse. It's hard to parse as a machine or as a program. And one of the problems here is if you're trying to return an error that represents, say, like a 404 code, and it's like a not found error, you'll see all kinds of code that ends up looking into the string and searching for the words not found, or doing kind of awkward things like that. So that's one of the things they're aiming to solve as well in Go too, is improve that. So enough of error handling. We're going on to concurrency now. So GoLang, or concurrency, is when, for anyone who doesn't know, when multiple things are happening at once. People call it multi-threaded. In GoLang, it can be multi-threaded. Rob Pike likes to make a point that concurrency is not parallel and it's not always multi-threaded. It's just a way of thinking about multiple things happening at once and constructing your program to model that. But GoLang prides itself on being super effective at modeling concurrency problems. It has first-class threading with Go routines. In addition, there's like channels. That's a built-in type that's a thread-safe message passing queue, sort of. And yeah, so here's just a little snippet of using a channel. So I'm going to do like some live coding to show you guys this, because I thought it would be a little easier and break up looking at slides. So,
Because live demo is always good.
oh yeah. Luckily there's no networking involved here, so I hope it'll work. So this is another simple counter example, but this one I have like, so I have this one package, it's called concurrency test, mainly because I'm adding tests in the same package for the sake of the demo. But, so there's one struct here that is called counter. It just has a counts map that's a map from string to int, which we're going to use to keep track of counts for different strings. We're just initializing the counter here, and then we have an add method on the counter, which is going to just increment at that name. So you'll pass a name and it'll add +1. Then we have get on the counter, which is just going to get from that internal map. And so this test example here, test sync, I'm not doing any concurrency yet. This is just all single threaded. We're creating a new counter. We set run count equal to 5. We are doing a for loop 5 times and calling add for the name Alice. So we're calling add on the counter, and then we're going to get the count for Alice after doing that. And we expect at that point the count should be equal to the run count, otherwise we're going to throw an error here. So let me go into, so here's that test file. So to run tests in Go, you just do go test. So, all right, it passed. So everything looks good so far. Our simple example is working. So how do I make this into a concurrency problem? Well, in GoLang, you just type the word go before a function call, and it'll spin off a Go routine. And basically what a Go routine is a lightweight thread that may or may not map to a real thread. It's kind of a virtual thread. And so calling this here is going to spawn off an add. It's going to run in one of these threads. And it's going to do 5 of these really quickly, and then we're going to call get here. So if I try running this now, it's going to fail. It says expected Alice to have 5, only have 0. So the reason it's failing is because we're spawning off a Go routine, or 5 Go routines, and then we're immediately calling get. And so the Go routines haven't had time to get scheduled and run yet at this point in time, so it's going to be 0. So there's a really good concurrency primitive in GoLang to deal with this, which is called a wait group. And basically what it lets you do is wait for the Go routines to finish before you can continue on with your program. And so I'm going to create a wait group here. So It's just in the sync package. You create a wait group. And the way you use a wait group is before you spawn off a thread or a go routine, you're going to call add on it and pass the number of items you want to add. So I'm just doing one go routine at a time. And now I need to extend this into an inline function just so I can call more stuff. And so I can add a done, which is going to indicate that basically subtract one from the wait group and tell it that one of these threads or go routines is done. Ideally in Go, you'd actually do this with a defer at the top, or at least that's what I would do, which a defer, if anyone doesn't know, will, at any point when this function exits, will end up calling that function. So it's kind of like a try finally in some sense in other languages, but the nice thing is if you panic or something like that, it'll get called. So now everything's almost good here. We're adding, we have the done. The one thing we still need to do is a wait, which basically just says wait until the last done has been called. So at this point, we should be able to call this test again, and it's passed. So things seem like they're good now. We're able to pass the test. Let me try increasing this run count to 80. So it worked the first 2 times, and then the third time it says expected Alice to have 80 but only have 78. That's pretty weird. So what's happening here, the map that we're using is not a thread safe object, and also the function, the way we're using it is not thread safe, because when we call add here, this plus equals basically evaluates to get the current value for that name, add 1 to it, and then set it back to the map. And in this case, we skipped over, there were 2 of those happening at the same time. We got the current value, added 1 to each of them at the same time, we set it back, and then it only went up by 1. And so that's what happened here to give us only this 78 of 80. So this is a thing where, or this is a problem that you can have a lot in GoLang, which is sort of race conditions. And even if you have tests like I had before, that one with the run count of 5, it'll pass a lot of times. So something to look out for in code reviews, but there's a way that you can actually get it to fail for at least a lot of these examples, which is using the -race flag when you're running tests. So I would recommend always using -race for any of your tests, because it'll kind of suss out a lot of these issues. But if you run it, this is with the 5 again, now it's failing because it says race detected during execution of test. And the race flag, basically what it does is runs a ton of these at the same time and does some other magic to kind of detect when memory gets poisoned or whatnot. So use the -race flag, it'll help you a lot. But so the way to fix this is, the simplest way in this case is using a mutex. Even though Go is really into channels, for this simple case I would use a mutex. So what a mutex is it's basically a locking primitive that just creates a lock around a resource while you're accessing it, and then you unlock it as soon as you're done. And that allows multiple threads to, whoever gets there first to unlock or locks it can access it, and then the next person, as soon as it gets unlocked, will get to access it. So it kind of serializes access to a resource. So I'm adding a mutex here to the counter, and I need to add it to the initial or the constructor here too. So I'll do that. So in order to use the mutex, again, you want to lock. So it's on the counter as mutex. So I call lock on it before I'm updating this map, and then unlock So similar here to before, I would use a defer ideally, because especially as this function grows, you want to make sure things are getting locked, that if they're all touching that map. So again, this is just going to lock before updating and accessing this, and then it's going to unlock at the end of the function. And similarly, we should add this to the get. So this time anyone is touching, or this way any time that someone is touching the counts map, it's going to get locked and then unlocked as soon as you're done. So let's try running this again with the dash race flag, and it passes. So cool. Yeah, so in GoLang there's a lot of other like concurrency primitives, including like channels is obviously the main one that everyone's really big on. I'm not gonna talk too much about channels today because that could be like an entire talk for someone to go into channels. But this is actually a graph that I found in this cool paper that talks about Go concurrency, and it's sort of some major projects. You see Docker, Kubernetes, etcd, CockroachDB, gRPC. So these are some of the bigger GoLang projects in the open source world, and it looks at different types of concurrency primitives and their usage. So even though everyone talks a lot about channels in Go, people are, even in these top projects like Kubernetes, they're using mutexes 70% of the time. So don't be afraid to use a mutex if it's a simple resource that you're locking like we just were. But you want to use channels if you're doing any kind of like communication, and especially if it gets to be a more complicated problem. Writing that same problem we just did in channels it'll be a little bit more verbose, but it'll probably be a more type-safe and future-proof implementation. So it's something to think about. Like, you shouldn't always just use channels or try to do something with channels if you can't do it. Or you should be open to the different types of concurrency primitives. So I can show you with that. I'm not going to live demo this one, but I can show you with an example of that same problem using channels. It's a little bit more code here. But basically what I did here is I set up two constants, one for add and one for getting. And then I have two structs now. One is the increment of value, and so I'm passing a name in that struct. And then the get value, I'm passing a name. And then also a response channel that's going to be used to tell me the result that I'm trying to get. And so now my counter has two channels on it, one for any increments that are incoming, and then one for any gets that are incoming. And so now with my counter, I can start it, and it'll create one of these counts maps. It does a for select, which basically it select in GoLang. It's similar like a switch statement, but it'll basically block on each of these cases until one of them has something in its channel to get. So in this first case, we're looking if we have an increment that we need to run, or if we have a get. Otherwise, this is just going to sit there and block forever until one of these hits. And then the for around it is basically a while loop in GoLang, which just tells it to keep doing this. So I don't actually, you'll see I don't have any like, I should have some kind of graceful shutdown here, like probably a context or something. But I don't have that because there's already a lot of code to build this. But so yeah, just to create a new counter, you now have to create these two channels and then start that counter here. And then the start is basically going to run as a Go routine that's always running in the background. But again, it's not going to be active most of the time. It's just going to be sitting there waiting on data from the channels. So now the add looks like, this is what it looks like. So we're basically just going to take the name and put it into one of these increment value structs and pass it into the increments channel, and the get will do something similar, but it includes a response channel that we use to then wait on and get the result. So that's how you can do this with channels. You can see that this is a good bit more complicated than using the mutex in this case. So again, you want to think about what you're doing, and if it's something really simple like this example, you might want to use a mutex. But then as things get more complicated, there's some niceties about using channels, even for something like this, to scale the project. So that's actually my talk. I have a couple links here, so I'll put these slides online. I'll put them on, link them on the Go Meetup or something so you guys can get to them. But this last slide has links to, there's a lot more details about code review comments that I didn't get into because obviously I just focused on security, error handling, and concurrency. But if you want to look at these, there's code review comments is a really popular GoLang place to go to and link to for any kind of style issues that come up in your reviews, because they've mentioned a lot of these. It's kind of like a style guide in some sense. And Effective Go will go into a lot of depth about channels and how to do things in GoLang that are different from other languages. I also have one shortcut for you. It's mostly just a joke. But while I was doing this talk, I also created this site, which is powered by GoLang. But it generates random comments. It's codereviewcomments.com. And it'll generate random strings. So if you're feeling bored and you just need to like have some inspiration for your code reviews, you can go here and click through it or use the API. But yeah, so that's, if you guys have any questions about code review or you want to like ask anything, feel free. Yeah.
So one of the challenges that I see a lot is code reviewers will get frustrated at giving similar comments, many times.
Mm-hmm.
Also, depending on background experience and how new different people are to the project, if I visited two kind of senior code reviewers, you might get slightly different perspectives.
Yeah.
Have you seen any good references for documenting style in a project? So just to minimize the number of common questions?
Yeah, I mean, I think what I see a lot of people do is adopt like a style guide that's already online. So they'll say like, we follow Google's style guide.
Is there a good one? Because I looked at Google's, if I remember correctly, one of them, and it was too broad, right? People used it, but they still ran into the same.
Yeah, I don't, honestly for GoLang, I'm not sure if there's what the best or what the most popular one is. Someone else here might know. I usually just link to like these code review comments. This is kind of like Google's one, I would say. Like there's a lot of stuff here. Have you seen the code review comments stuff before?
I need to see this one to see if it's the one that I've read, but if
it's not quite as detailed as you might be talking about as far as like, yeah, if it's spacing and that kind of stuff, I would just use Go format for that, and then.
Yeah, no, the typical things that are more, right, so there's an architecture and a design, and you want to be cohesive to that architecture and that design, and then when folks are coding, right, there is definitely comments, that kind of stuff, and then are you being cohesive with the rest of the design of the system?
Right, yeah. Yeah, it's interesting problem, like, because it's almost, some of it's, you're talking about internal documentation, just like, this is how we do things, or.
Have you ever seen a good version of that?
Yeah, I don't know, not offhand, I'm trying to think. I mainly see people who have made style guides that usually is more of a, like, I've seen it for another link, like we had one at Dropbox for our iOS project, but yeah.
Airbnb is a famous one for JavaScript. There's a lot of people.
Yeah, Airbnb, yeah.
It became the ESLint standard. I think a lot of people really jump forward with that.
Yeah.
I've heard people say for GoLang also look at standard library code.
Yeah.
It's like one of the comments you hear, which not everybody wants to do. It's supposed
Yeah.
to be, very well reviewed.
If you run Go Meta Learner, it'll give you a lot of the errors that point to these code review comments. I actually usually just take, and there's handle links at every single one of them, so you see somebody making the same mistakes, you know, and we're just like, hey, here's something on, you know, Go Metaliner. It runs like, you can choose which one you're gonna run, but yeah, it runs a whole slew of different reviews, and
It's kind of like yes,
good and bad. Yeah. It's also depersonalizes it too. People don't get mad because you're pointing to a web page and like, oh, Sean's a jerk. He's saying the same thing to me.
Yeah, that's the style that can be tricky. We see that a lot at pull requests. Like we try to stay away again from like, we'll recommend people use a format or adopt style, but we don't want to like nitpick on a lot of things because everyone's different on what they so.
There's something I've seen in some open source projects, but I haven't seen yet in a professional setting, and that is opening up branches against other people's branches and submitting PRs to their branch that they have an open PR to. Is there any like merit to that kind of ecosystem in your opinion?
I think it's kind of cool. I've never seen that. I've never worked on a team that does that, but I think it's a cool, especially if it's like annoying things that the person. It's actually, GitHub has a cool new feature. You can do suggestions. I don't know if you've seen that, but you can actually in your comment leave like, it only does this current line.
Yeah.
But it'll like, they can just hit accept and it'll. Yeah, this is kind of like a larger version of that.
Okay.
Yeah, if you hit accept, it'll just do a commit onto their branch.
Interesting.
Yeah, that's a cool idea to. I think that would be. It could get a little dangerous if someone's like always pushing stuff and you're like, I don't agree with what you just pushed to my branch. But
the context that I had seen this actually one time was when I was working with a team in a vastly different time zone, and so it was actually more efficient to.
Oh yeah. Yeah. Yeah, I mean, I think a lot of people have different code review styles, and we've seen a ton at pull requests, but there's some, like, you'll see, like, you can find YouTube videos of people doing code review, but they're really just editing someone's code and submitting a PR for it.
Yeah.
Which I think it's pretty common, yeah, remote teams more.
Okay. But
Yeah, I was just gonna say, we've done that. It's generally a practice of last resort. My whole team is distributed all over the place.
Okay.
And so if you can't get somebody via Slack, if you can't get them to actually do a pair programming session right then, and you basically say, okay, you know, I'm gonna go into your branch and I'm gonna, you know, and it's usually after you've tried to coach them 3 or 4 times in a certain direction,
Yeah.
and they're just not getting it, then, but you take yourself out of the pool of being able to review that PR then by doing that.
Oh, okay.
So,
Yeah. Yeah, I think could help with if there's any kind of lapse in communication,
Right.
especially.
Yeah, it makes sense to take yourself out, because now you're
yeah,
the
because now you're
author,
part of
so
the branch,
yeah.
so.
It's like approving your own PR.
Recuse yourself, is that like?
Yeah. Recuse. They need to add that button to.
Tyler, I got a question for you.
Yeah.
I went through a long thread on Twitter recently about, you know, our culture of code reviews itself. That everything's tone is always negative, right? People, nobody ever says, "Yay, I made a bunch of mistakes," right?
Yeah.
You know, it's always assumed that they're only out there to tell you what you did wrong. And a friend, you know, saw my house. She put, "Hey, this is really nice. I like how you did this." And you know, out of context, a remote team, like remember later on, I spent 4 hours looking at my code. I don't understand what's wrong with it. Why, you know, what's the snarkiness for, right? And she was like, no. You know? And I was wondering how you guys deal with that at pull requests. I mean, you know, is there any way to frame a comment where it comes across more sincere? Because there's just no tone, right, in some of these sessions.
Yeah, so we pay a lot of attention to that. It's actually, it's interesting, we have a unique perspective because we have some, like it's a new person to the team that isn't on the team, so there's no history there of like how they like left comments or how do they act at work. So people are usually actually friendlier to us than they would be, I think, to a teammate, which is kind of surprising, but yeah, so we have an interesting perspective there, but we try to be very, like we've had some customers that are like, we want you to give stern feedback, but we try to do it in a way that we're not, like we say, as long as this is up with your best practices, pay attention, you might want to look at this. But I think because it's coming from us as a third-party source, it's almost like if you get lint errors or something, you're not gonna like get mad at the robot necessarily. So because we're kind of also a third-party source, people give us more leniency, but they usually expect that we're not being snarky, I guess. But yeah, we try to suggest things like, you might look into doing this. This is a good, like, do kind of suggestive references like that instead of matter of fact things. Like if you say this is wrong, then it starts off kind of aggressive, and someone might, even if they agree with it, just be confrontational about it. But
On the flip side, do you guys offer positive feedback on the other side?
yeah, I mean, we try to encourage our reviewers to add a lot of positive feedback, especially because we don't want to do like looks good to me or thumbs up on a review, because we want to make sure that people know that we read through the whole thing. So we like encourage our reviewers, like, find something in there that you liked and comment on it, even if there's no issues, because you want people to know that you actually cared. And people actually, they respond well to that, and they really like the fact that someone read their code and cares about it.
We're actually allocating the feature as well for kudos, we're calling it, where our reviewers can give a reviewer a reviewed line of code or section of code